Are you able to see the screen?
Yes, sir.
Just give me a minute. Okay, now I guess the screen is visible for everyone. Anyone can give me input?
Yes, yes, sir. Yes, sir.
Okay. Okay, so let's start with from where we have left, that is unit number 1 from section 1, subject CCM. Now, before we could start, uh, maybe by tomorrow, if we don't have holiday, or maybe on Monday's first lecture itself, we'll have a test. Will that be okay with you all? Are you prepared now? Now, who will say yes?
But in which way, sir?
We'll go ahead with the MCQ test only. So what we will do is I'll share you some a platform, kind like if it is possible, online itself, like when the lecture is going on there itself we can complete that test, or otherwise if not possible we'll conduct on this Google, which is by with the help of Google Sheets we can go ahead with. So won't be any problem. The mode of conducting the test would be easy. That won't be too hectic, and questions also I'll keep it very easy, so that whatever basic understanding that you have, you should be confident enough about it. The only purpose of keeping this test is I'll come to know how effective this platform is, and whoever attending the test, are they attending it seriously, or it is just like people are like using their cell phones, keeping it in mute and keeping it somewhere and start watching TV or some other things. So that should not happen. Just to check the feedback only, I wanted to take this test. And obviously, in order to like, you should feel the heat of it. So I'll consider these marks in your term note as well. So those who are doing it seriously, they should get benefit out of this. Am I clear with this? Don't
Okay,
worry,
sir.
don't worry. It won't be that tough or something. And I think being final year students now, none of you are actually afraid of any kind of tests. So you're taking the tests very lightly. Same way I wanted you to take it very lightly, but sincerely. Don't take much of burden or tension. Just go with the flow. Whatever you have learned, whatever if you have paid say 60-70% of attention also, you'll be able to solve this very easily. Okay, so with this note, I'll continue with the lecture. So today, mostly we will cover within say 5-10 minutes about what we have done previously. Then more 5-10 minutes for revision of the all the layers and a bit details into each of the layer, and then we will start ahead with the chapter number 2 for second layer of computer network, that is the data link layer. Still people are joining. Swapnil, Darshanali, Nikita, Nikita, you should join on time, please. Next lecture onwards, you keep this in mind. I can understand in between some session was there, so it's okay for today. Okay, so as we said, let us start with the revision of chapter number 1, what we have seen in previous class. So we have started with the first chapter, data communication. These are the points why networking is needed. What do you understand by layered layers or layered communication? Which model is preferred, or which is the reference model that has been used, which is OSI reference model. Then what exactly the protocol suits that has been used, like different set of rules that have been used for computer networking nowadays. That is nothing but the TCP IP suite. There has to be a slash here in between TCP and IP. There has to be a slash here. That is how we denote it. Then the comparison between the OSI and the TCP IP, and last point was the network topology. So what we have seen in first 2-3 points is networking is essential in order to ease the work, in order to go ahead with easiness in the maintenance and all. So layered communication, when we prefer, we ensure that we get involved ourselves into a distributed network where same task can be done by many people, many programmers, and whenever they're doing it, it has to be in a layered format. That means a big, huge task will be divided into sub tiny tasks, and those tasks will be completed by the several other users which are taking part into the communication. Then this is the example which we have covered for understanding the network layered communication, where a person is sending a letter to, or this is the sender sending a letter to the receiver, then message from sender in order to reach it to the receiver, how that message travel into different layers, and based on that we have divided it into high layer, middle layer, and lower layer. Similarly, in our networking also we have several layers, like for example in OSI reference we have 7 layers, and in TCP IP we have 5 layers. Now, when we go ahead with layered communication or layered architecture, by splitting the task into multiple tiny tasks, so we can get rid of these issues. Like these issues will be resolved if we go for layered communication, in which bandwidth would be issue, error correcting, flow control, addressing, multiplexing, naming, congestion control. Congestion control is again related with the flow control. Then the mobility, the routing, the way the data travel, the fragmentation, how a big data can be split it into small piece of data. Then the finally important is the security, where we go for encryption and the decryption of the data that we are going to transmit. So all these issues will be resolved if you go ahead with the layered communication, because in order to deal, suppose here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Suppose we have 12 issues here. Instead of one layer to resolve all the issues, what we did is we have assigned all these 12 issues to 7 different layers, so that each layer has to deal with only one type of issue. So obviously that will reduce the complexity or burden on any one particular layer. That is what the agenda for layered communication. Then we have seen the OSI reference model, which is actually a reference model only. That means we are not actually using it; it's a theoretical model only. Then we have seen what are the different layers into OSI reference model. So total 7 layers, starts with physical, data link, network, transport station, presentation, and application. So 7 different layers. We start with layer number 1 by considering that we are thinking about receiver side. But when we talk about the transmitter side, then application layer will become our layer number 1. And that kind of question people ask in examination, like which is the third layer in OSI reference model. So it's an invalid question actually, because when we say third layer, we have to specify, the user has to specify whether it is the layer from the transmitter side or it is the layer at the receiver side. But for your sake, consider that whenever it is not referred, whether it is receiver or transmitter, we always consider that as a receiver only. So by default, when we talk, the physical layer will be our layer number 1, and application layer will be our layer number 7. So at the in maybe next 5-10 minutes, we will again revise in detail about what the layers are supposed to do. That is how the architecture, we have discussed this in yesterday's class, that there is a thin line here till that, sorry, till the transport layer. Before, below transport layer, whatever the layers are, that is physical, data link and network, these deals with the hop to hop communication or system to system communication. But transport layer onwards, all these layers are responsible for process to process communication, and transport layer is exactly at the midpoint or junction point, where transport layer is the one who actually started giving additional address here. Like till physical layer, we just need to make physical connection. At data link layer, we have to define the MAC address of the machine, which is the number of that NIC, that is network interface card, that comes along with every computer. That card, which is permanent address of any machine, whether you take that machine to say Europe or Africa or somewhere else, the PC or computer which is connected in, which is manufactured in, say, suppose in India, it has one address that is referred as MAC address. And that MAC address, it will be the MAC address, it will be continued till wherever you go. Like, it is a permanent address that I was talking about, which is given by the data link layer, which is generally of 6 bytes. Even if you use your, so Vare and Chauhan, you're very late now for joining for the session. So I understand for today's case, because there was some previous session. So next time onwards, you should not be late. Okay, now so you break the link now. Okay, so this data link layer, what I was talking about, it will have a MAC address, which is machine address. Even though in your mobile phone itself, once you go into your phone details, and then there also you can find out that there is an address assigned for, even your Wi-Fi has an your Wi-Fi setup has an dedicated address assigned for your system, which is basically a 6-byte address, which is a permanent address. Even though you format your mobile or whatever you do with your mobile, or you have connect that with Jio or Airtel, or say even college Wi-Fi also, it doesn't matter. The address for that, physical address for that cell phone will remain same. That is the address which is given at data link layer. We sometimes refer it as a physical address, which is the permanent address for any machine. Then next, there is a network layer, which gives you a network address, which is nothing, which we call it as an IP address. Suppose you enter from one network to the another network, then your IP address may change. Now you can have a different IP address assigned for your computer or for your machine. So from different one network to another network, if you switch, your network address may get vary, but your physical address, which is assigned at data link layer, it will remain same. Now what I was talking about is, first 3 layers, they will assign a physical address for that machine itself. The address will be till that machine. But once you enter at transport layer, there will be additionally, along with machine address, additionally along with the IP address, there will be a port number assigned for your the data packet that it travel. म्हणजे प्रत्येक डेटा पॅकेट सोबत एक पोर्ट नंबर सुद्धा आपण पाठवतो, आणि त्या पोर्ट नंबरला एक स्वतःचा ऍड्रेस दिलेला आहे. रादर त्या पोर्टलाच प्रत्येक ऍप्लिकेशन वाईज एक वेगवेगळा नंबर असतो. What does this mean? It means that if you are using, say for example, if I am using a Google Chrome, then the Google Chrome will have certain port number. Then if I switch from Google Chrome to certain, say for example, if I am switching to certain a networking game or certain app in which I need to install the, I need to get connected with the network, then there will be certain different port number assigned for that, which means whatever different applications, whatever different apps that are there on the machine. It may be a phone or it may be a computer or a laptop, depending upon whenever we try to connect with that particular machine, then every application will have its own port number, which comes exactly at this layer number 4, which is the transport layer. So I will revise this once again. At physical address, there will be physical connection. That means port will be available. At data link layer, there will be machine address, or we call it as a MAC address, which is 6-byte address, and that is permanent address for that machine. Wherever you go, the address will be there along with that particular machine. Then at third layer, for the network layer, there will be a network address, or which is popularly known as IP address of that particular machine. So this IP address, it may vary depending upon you switch from one network to the another network. And then lastly, at transport layer, there will be another address which is referred as port number. And port number indicates which application or which application number the data wants to have access of. Suppose if data is transmitting from Google Chrome, say for example, this person here is using WhatsApp, and here also there is a mobile number in which WhatsApp is being used. So the data now travel from WhatsApp of this person to WhatsApp of this person. So WhatsApp itself will have a different port number. So obviously data will travel from one computer to another computer, or one mobile to another mobile. But in the mobile itself, the data will not be dumped anywhere else. The data will direct it to the application, exact application where it's supposed to land. And for that, we need to define which process or which application is running, and which is the responsibility of this transport layer. I think I have made myself clear. You people are hearing my voice as well as you can see the screen, right?
Yes, sir.
Okay. You got this point, Amit?
Got it, sir. Got it.
Okay. And then further 3 more layers which are indicated by a different color. Those are again, we refer them as in software layers only. So all bottom 3 are hardware layers mostly. Here we get connected with the process, and all above 3 layers will be the software layers. Okay, then this is how whenever data travel, each and every along with each and every layer, a header will be added to each of the data. And we have seen in detail what do you understand by header, because every layer will have its own role to play, and each layer will add some of its data along with the some of its contents along with the data, and those are referred as headers. Then in brief, we have seen what are the, this we have seen already. In brief, what is the role of every layer. Then we have seen TCP IP protocol suite, which is the actual set of rules with which the communication took place, or with which the entire communication is built. Then we have seen the comparison between these the previous version of TCP IP suite to the new version of TCP IP suite. Only changes that has happened is rename from internet layer to the network layer, and network interface layer, and hardware device. That way, this was not, hardware device was not a layer, but network interface was the layer, which is subdivided into 2. That is the physical layer, which is same as that of the OSI. So that with this, it will be easy for you to link. Then this is the comparison how 7 layers are divided into only 4 layers. Now here comparison is shown with the 4 layer, but here you can have distinction that there are 2 layers. One is physical, another is data link. And what top 3 layers, that is application, presentation, and session layer, all 3 will be combined together and call it as an applications layer. Okay, then last part that we have seen yesterday was network topologies. Now topologies means the way we make the connections, with the way we make the computers connect with each other. So depending upon how we connect, there are different topologies. Those topologies are mesh, star, bus, and ring. When we talk about mesh, this is the one of the most reliable topology. सगळ्यात विश्वास ठेवणारी कुठली टोपोलॉजी असेल तर मेश टोपोलॉजी, because there is a dedicated link from one machine to the another machine, so that even though anything happen with any of the network, any of the machine in the given network, the communication will not fail at all. Then in mesh, as the connection is dedicated from one machine to every other machine, so there is no problem for, like here you can see, this is how the mesh look like. So if dedicated connection is there, there will not be any problem of congestion of the data, there will not be any problem for flow control. It can be easily done without any issue, and that is why mesh is most reliable topology. But unfortunately, with number of systems increases, mesh will become much more complex, because number of wires required will be huge, and at the same time every machine should have those many number of ports. So number of ports required for a machine will again become a very complex phenomenon, and that is why generally mesh topology is not been preferred. The next topology was star topology. Now star topology means there will be an intelligent device at the center through which all the machine can communicate with each other. म्हणजे सेंटरला एक इंटेलिजंट डिव्हाइस असेल की ज्या डिव्हाइसला सगळं माहिती आहे की डेटा कोणाकडून आलाय, डेटा कोणाला पाठवायचा आहे. So all the details will have with that particular intelligent machine, which is sometimes a router or sometimes a hub or a switch also. So that device will ensure that how to involve all the machines into the communication. So all the machines, they only interact through the central device, and that is how your star topology works. This is what the example of star topology. So all these stations, all these 4 stations will communicate with each other via hub only. Then next topology is your bus topology, in which it is very economical topology, because there is only one network cable that people have to lay, the network people have to lay, which is terminated at both the ends, so that whenever certain data transmitted from one machine to other machine, the data will travel through the common bus connected, and each station will receive that data. It will check whether it is for me or not. If it is for me, then that machine will accept that data. Otherwise, it will again drop that particular data on this cable, and then it will travel further. Then this station will check whether it is my data or not. If not, it will keep it on the cable itself, and the data travel till it reaches to the station of which the data is available, and then it can be the communication can be closed. This is how a bus topology works, but it has several disadvantages. What if this link breaks? What if we need to add new connection? So things become much more complicated. And the last topology that we have discussed is the ring topology, where all the machines are connected with 2 neighboring machines, forming a circular connection into the network. But here also the complexity has reduced, but here problem will occur that if at all any machine fails, the entire communication will collapse. So these are the advantages and disadvantages of all the network topologies. Then last one was the hybrid topology, which is the mixture of all the topologies. So depending upon the situation, depending upon the requirement from the customer end, we can go ahead with any of these 5 different topologies, out of which hybrid is the one where there will be a combination of all the different topologies altogether. Now in this example we have seen a bus topology is combined with the star topology, and that way connection has been made. Then this is the summary chart where we compare all the different network topologies, like advantages of and disadvantages of all individual topologies I have mentioned here. Okay, now as I promised you in yesterday's class that we will recap all the layers once again, a bit details than that earlier what we have seen. Other than that, we will go a few more detailed points into each of the layer here, and then we can get started with our chapter number 2. Now the physical layer. Now, still I am audible, right? There is no break in the connection.
Yes, sir.
Okay. Okay. So physical layer basically it coordinates a function that require to carry bit stream over a physical medium. Like what I have told you earlier here, that all the different layers. Okay, so all these different layers here, as it is basically a communication between a computer machine which is connected here to the computer connected here. So all the data that will be passing through, it will pass through all 7 different layers at the transmitter, and again all different 7 layers at the receiver side. As the data communication is like as the machine is involved into the data communication, all the data is available in the bit format or bit stream, that is ones and zeros format only. But whenever we wish to transmit it over a communication channel, now channel can be of 2 types. It could be a wireless channel or it could be a wired channel. So when we go ahead with, like, mostly we deal with the wired channel only. So whenever we go ahead with the wired communication, we have to send or we have to convert the bit stream information into an electrical signal, and that electrical specifications we need to define. Then we have to ensure that whenever data get travel, how the mechanical connections are, how the mechanical connections should be, or how the mechanical interfaces could be. Like, say for example, at the back side of your computer machine, if you check, there are various way via which we can connect with the outside world. Like there would be an HDMI cable, there could be a DB21 connector, there could be a DB9 connector. Like DB9 connector, which you connect to the your what we can say, in your class we have no projectors and all. So there you can go ahead with the DB9 connector, which follows that RS232 communication standard. Then you have now USBs also. Through USB you can get connected with the outside world. Then there is a HDMI cable. So all these are the mechanical interfaces with which your computer is connected with the outside world. So physical layer not only focus on the electrical specification, but it also focus on the mechanical interfaces as well. So physical layer is basically responsible for the mechanical interface and electrical specifications. Then how it has been done? So this bit stream is converted into which travel through the wires, which could be a twisted pair cable, which could be a coaxial cable, which could be an optical fiber, and even if we go for wireless communication, then the air could be the medium. So this way, in different transmission mediums, the wire, like twisted cable or coaxial or optical or air could be one of the medium, the data is need to be transmitted. So generally it is represented, like bit is represented by the voltage levels of the logical values. Like, say for example, depending upon which port connections that you are using, like even if you consider for USBs, the generally voltage is 3.3 volt, the voltage levels. But if you go ahead with the DB9, there the standard voltage levels are in the range of 5 volts. So that way, all the ones and zeros values, those are called as logical values. From them, we can derive the voltage levels for each and every signal. Then we don't not only define the electrical connections, we also ensure the data rate, which is very popularly known by the baud rate, which you generally select in your practicals or even the programming also, while with the help of say Bluetooth module or with the help of Wi-Fi module. There also you get involve yourself into deciding the baud rate or the speed of your data or data rate, we can also call it as. So this way, physical layer is responsible for all of this by selecting the media types, by bit representation, that means the voltage levels, that is electrical specification, the speed, and the synchronization of the bits. So all these will be the responsibilities of the physical layer, which we will be studying in detail in chapter number 4. Then there is next we referred as an data link layer. So data link layer is responsible for moving frames from one hop to the next. That means node to node. That means there will be different machines with the help of which we want to transmit our data from machine 1 to machine say 6. So in between, if a continuous connection is there, then the data has to travel from one node to another node, and the responsibility of that is to whatever intermediate connections were there, whatever intermediate machines are there, those are called as hops or nodes. So whenever data communication took place from one machine to another, the data generally travel from one node to another node, and the responsibility of data link layer is to make sure that data will reach from one node to the another node, or hop to hop communication is basically the responsibility of data link layer. Then other than that, this is the main principle for data link layer, that hop to hop communication is the main tagline. But in that tagline, what are the responsibilities that data link layer does? So data link layer go ahead with framing of data. That means raw ones and zeros will be converted into a frame of data. म्हणजे you can just take the example, suppose take example of any like तुमचे जे बिस्किट पुडे वगैरे असतात त्याचे एक्झाम्पल्स घ्या. त्याच्या आतमध्ये छोटे 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 असे बिस्किट्स ओळीनं सिरियली माउंट केले असतात, आणि त्याच्यानंतर तुम्ही त्याच्यावरती रॅप मारलं की झालं ती एक फ्रेम. सो दॅट वे whenever we decide to involve data link layer, then we ensure that all such tiny data, that means all those ones and zeros bits will be clubbed together to form one frame, and that frames will be transmitted, not individual bits. So framing is one of the key job of this data link layer. Then physical addressing, as I told you earlier, there are two kinds of address every machine has. One is logical address, that is IP address, and another is the physical address, which is MAC address, which comes along with the NIC card, network card. The network card ला तो स्वतःचा address असतो, which can never be changed. So physical addressing is also the responsibility of data link layer. Then flow control and error control. Now flow control and error control are equally important, because not necessarily all the machines which are connected in network has same working speed. Like every machine is not made up of similar kind of processor and clock which can work at the same speed as other machines are working. So every machine which is connected in the network is very much possible that is a different machine working at a different speed, and therefore we need to involve the flow control mechanism at data link layer. Then next is the error control. Now whenever communication took place, whenever the data communication is there, all the values are in the form of ones and zeros only. So there is a huge chance that the error may took place, and that error control, that means error detection and correction, is responsibility of the data link layer only. Remember, it is the error control at hop to hop level only. That means from machine to machine, not between process to process. Lastly, most important feature that data link layer does is the access control. Access control means what? If two or more machines are using a common path, who should use that common path? That decision has to be taken, and which is taken by the data link layer under access control. म्हणजे दोन जर नेटवर्क असतील ज्याच्या आतमध्ये 100 मशीन्स असतील आणि दोन नेटवर्कला जोडणारा एकच रस्ता असेल, तर कोण पहिलं जायचं, कोणी ते डेटा तो कॉमन रस्ता वापरायचा, all that decision will be taken by the data link layer under access control. So the same thing as I have told you, same thing which is mentioned here, but only in the graphical format. All these 5 responsibilities are mentioned here. what graphical format will tell you is this is the raw data that you will get from network layer, and what you do is along with that data there will be a trailer added and a header added here. So header and trailer is added so that it will take care of all these 5 responsibilities. या 5 responsibilityची काळजी करण्यासाठी आपण हे ट्रेलर आणि हेडर ऍड करतो, ज्याच्यामध्ये फ्रेमिंग केल्यानंतर कशा टाईपचं केलेलं आहे त्याची इन्फॉर्मेशन टाकतो, फ्लो कंट्रोल कसा अचीव्ह केलाय त्याची इन्फॉर्मेशन टाकतो, ऍक्सेस कंट्रोलची इन्फॉर्मेशन असते, फिजिकल ऍड्रेस ह्याच ट्रेलर हेडर मध्ये असतो, आणि एरर कंट्रोलचे बिट्स सुद्धा along with the header and trailer only we transmit. So that means not only data travel from in data link layer, but along with the data the other information of related to that layer itself is also travel here in data link layer. Am I clear? समजते का? आवाज येतोय?
Yes, sir.
Okay. Okay.
Yes, sir.
थोडं तुम्ही जिवंत असल्यासारखं दाखवत बघा तुम्हाला. So the data link layer is responsible for moving frames from one hop or one node to the next. This is what the same thing I have told you. From this machine to this machine, if you wish to travel, then there will be several links. So say from A to D data has to travel, then it will travel through B, then C. If F is there in between, then from B to E and F. But how it has to be flow, that is responsibility of the data link layer. Okay, add the error correction, flow control related information, and here in header we add the source and destination addresses, so that whenever data is traveling from say 10 to 87, in between when the data is traveled, everybody which is taking part in communication will know that this data has came from 10 and it need to go to 87, so nobody else can touch it. Only 87 will have the access to receive that particular data, and this way along with your data all the related information also present. Then next is the network layer. As I rightly mentioned earlier, network layer is responsible for delivery of individual packet from the source host to the destination host. Only thing which is remaining here is irrespective of whether they are part of one network or some different network also. That means network layer is responsible for interconnecting the internetworking of the data. That means the one machine which is the transmitter could be part of network A, and which is the receiver, the machine B which is the receiver, it can be part of some network, some other network which is different than the first network. So that way interconnection between two different networks is the responsibility of the network layer. And in network layer main responsibilities, major responsibility झाली इंटरनेटवर्क कनेक्शन. पण त्याच्यामध्ये नेमकं तो काय करतो, तर it will complete the job of, it will do the job of logical addressing. That means it will define the IP address for every machine, and most important thing that it will do is it will involve into routing. That means how the data will travel, which is decided by this network layer. So this is how the source to destination. Same example here, only the thing is here the yellow line. Now to destination delivery will be the responsibility of network layer. Here you can see in this diagram, the responsibility of data link layer was between hop to hop. Like say for example, it is responsibilities from A to B. Now it is B's responsibility that data should reach to C. Now from it is C's responsibility that data should reach to D. So network layer is responsible from hop to hop. But here if you can see, the network layer is responsible from source to destination. I am not saying between process to process. I am saying source to destination, that is from one machine to another machine only. So in between, hop to hop is there, so data link layer will help it, but data should reach from A to B is responsibility of the network layer. Getting it? Yes. Okay. So
Yes, sir. Yes, getting.
so next is the transport layer. So the transport layer is responsible for delivery of message from one process to another. As I told you earlier in this lecture itself, that I'm repeating the things. Please spare me, but it is important. That's why I'm repeating. Here in the bottom three, only machine to machine connection is there. Only machine to machine connection is there. But transport layer is the one where process to process communication will be there. That means here in detail I can show you now. Okay. Okay. So as in transport layer, as I told you, the responsible for delivery of message from one process to another. Now, one process, that means the process which is running on one machine has to communicate with the same process which is running on another machine. So it is responsibility of this transport layer. And त्याचे सब points काय काय येतील तर service point addressing means end to end addressing. Here we will address the port number, segmentation and reassembly. Now here generally if the data is very huge in number, we go for segmentation of data, means huge data is divided into segments. Say if data is say containing say 1 lakh bits. So what we do is we make different segments of say 10,000 bits in one segment, and that way we name that particular block as segment number 1, then next block as segment number 2, then next block as segment number 3, and we define numbers to every segment, and then the data communication would take place. And at the receiving side, again, whatever different segments are there, those will be regathered or reassembled all together. Then connection control, flow control, and error control. Now these 3 points have came same as that of DLL. But remember, DLL was from one hop to another hop. Here it is from one process to another process. Then this is what segmentation I was talking about. So huge data which is coming from session layer will be divided into different segments, and then it will be passed on to the network layer. And this is what process to process delivery. That is from one machine to another, network layer will take care of. But from one process in machine number 1 to the same process in machine number 2 will be responsibility of the transport layer. The next layer is the session layer. Session layer is responsible for dialogue control and synchronization. Now this is very important because whenever we ensure that the connection is established. So right from establishing of that connection till the connection get over, all the responsibility lies with the session layer. So all the handshaking, synchronization, all those signals will be under the session layer's belt. Next is the presentation layer. Now, as I told you, presentation layer is important layer because all the machines which are part of the network may not be using the same language, may not be having the security feature along with the every machine. So whenever data travel, then translation of the information, the compression of the information, and encryption, that means providing security to the information, is the responsibility of presentation layer. And last layer is nothing but your application layer, where there will be n number of applications which are directly getting connected with the machine. So end user interface with the machine is the responsibility of the application layer. Now it could be anything. It could be a program, it could be a machine, it could be a human. But in order to connect them, with the machine, with the end machine, is the responsibility of application layer. And whatever the applications that we use, the reason why in your Google phone also, whenever we try to install any app from Google Play Store, that app is basically a short form of the application. And why we refer it as an application? Because if we want to have a video signal which is sent from one friend, one transmitter to the receiver, then the receiver and transmitter both uses an application called as WhatsApp to transmit that video signal. So data is WhatsApp. Your system is nothing but your mobile phones, and that data you use to transmit, which is interacting with the user, is nothing but your application, which is your WhatsApp application that you are using. So that is why application layer is very important, because it controls these kinds of several hundreds of different apps or different applications, with the help of which user can get connected with data which is present on a machine. Machine वरती अवेलेबल असलेला डेटा जर युजरला मिळवायचा आहे, युजरला इंटरॅक्ट करायचा आहे डेटा सोबत, युजरला तो डेटा हवाय, तर त्याच्यासाठी त्याला ऍप्लिकेशन लेयरच वापरायला लागते. That is what the importance of application layer, and that is what the end of your chapter number 1. So now you can unmute yourself. Those who feel there is some doubt, you can ask me, and we can, if no doubt is there, we can go ahead with the chapter number 2 as well. So I'll give you 1 minute. If you have any doubt, please ask. All yes, sir, and okay, sir. Is there anybody who has any kind of doubt? Anybody want to say something? Is it clear?
Yes, sir.
Okay, so shall we proceed with second chapter?
Yeah.
Okay. We have started at 1:45, right? So we still have 10 minutes in our hand. So at least we will begin with what are the syllabus contains and overview of this chapter, right? Is the screen visible?
Yes, sir.
Okay, voice is audible also, right? Okay. Now, this is one of the biggest chapter from this particular subject. It will take a lot of time, because as you have seen in the responsibilities of data link layer, you have came across that there are 5 responsibilities. One was the framing, another was error detection and correction, or error control, which is referred as. Second was flow control, then was the access control, and one more was there, I guess. Then okay, physical addressing, right? But that does not require anything, because that is responsibility of manufacturer only. Okay, so we don't have to waste our time on that. Okay, so 5 different tasks, rather we will call it as here 4 different tasks that this layer does, and that is why it is very important chapter and very huge chapter also, because it ensure that it will get involved into framing, that is forming the like clubbing the raw bits all together into a frame. That is what the responsibility of data link layer. Followed by, it will ensure that error control will be achieved. Now, error control means if at all any error occur, it will be detected and corrected. Now, remember, corrected here means the रिप्लेसमेंट ऑफ द करप्टेड फ्रेम. जर समजा एखाद्या फ्रेम मध्ये एरर असेल तर मोस्टली जेवढं पण कम्प्युटर कम्युनिकेशन मध्ये आपण इन्व्हॉल्व्ह होतो, आपण एरर मीट करायच्या नादी लागत नाही, आपण डायरेक्टली रिट्रान्समिशन साठी जातो, बिकॉज रिट्रान्समिशन इज इझियर as compared to error correction. Then next is flow control method, flow control mechanism. की जिथं आपल्याला we have to ensure that all the machines which are taking part into the communication, not necessarily all are working with the same speed. So we have to ensure that depending upon the capacity of the receiver side and the transmitter side, we have to maintain the speed of the information flow or flow of information as per the weakest possible link in the given network. So for that we need the flow control, different flow control methods. Now in our syllabus we have like we'll definitely not start with stop and wait protocol. Before stop and wait protocol, there are two more protocols. We will study those. Then sliding window protocol, piggybacking is one of the protocol. So all these are the flow control method algorithms, protocols that are being used. Then there is access control, which is called as MAC. So access control, it has again two types, collision oriented and collision based. So these two different types we need to study. And then Aloha, CSMA, CSMA CD, all these are the access control and flow control algorithms only. And lastly, we have to see a combined protocol for all these data link layer. Like all these features will be available into the HDLC frame. It is a frame format which contain all these different protocols. So HDLC we can call it, refer it as an, it is summarized the form of all these different protocols. Okay. Okay, till there, is there any doubt? Till this, is there any doubt?
No, sir.
Okay, so I guess only 4-5 minutes are there. So even if we start with framing, it will not be covered because we have to take two types of framing, bit and byte oriented. So I think we will stop here, and in the next lecture we can continue with this particular chapter. But before that, before you quit, let me check with the attendance. Okay. Okay, I'll just read the numbers which is there along with me. Then accordingly you can say unmute yourself and say yes, right? Or if any number is missing, just tell me, right? Roll number 47, Samir is there. 57, Kiran is there. 01, Renuka is there. 11, Shweta is there. 16, Deepika. 17, Geeta. 18, Ashwini. 24, Monali. 26, Sonali. 27, Smita. 28, Vare. 56, Ashtosh. Then 36, Swapnil. 37, Upendra. 38, Gaurav. 45, Salman. 15, Saujanya. 21, Shraddha. 22, Janvi. 23, Amruta. 35, Amit. 09, Khandekar. 10, Ishita. 14, Komal. 3, Snehal. 4, Ashwini. 5, Surekha. 6, Sanjeevani. 7, Abhilasha. 8, Komal. 12, Aishwarya. 25, Pratiksha. 53, Santosh. 32, Sushant. 52, Imran. 13, Shraddha. 19, Nikita. 20, Manali. Okay, now is there anybody left कुणाचा अटेंडन्स घ्यायचं राहिलं असं आहे? So shall I close? So I will consider that all these members' attendance is taken. Shall we close? Okay. Thank you.
Yes, sir.
Yes.
Thank you.